Every year, India harvests more than 21 billion coconuts. But behind its title as the Kingdom of Coconuts lies the reality that around 70% of coconut husks are piled up or burned. Today, India is turning this rough agricultural waste into a surprisingly green industry. From coconut fiber, they create erosion control mats, plant-growing substrates, premium mattresses, coconut shell charcoal, and handicrafts, then export them to demanding markets, such as Europe. From agricultural waste to high-value products. From discarded coconut husks to the green gold of the circular economy. How has this nation of 1.4 billion people managed to do it? Join Terran Works as we explore it in today's video. To understand why coconut husk recycling in India has become so noteworthy, we first need to look at the country's position in the global coconut industry. India is currently the world's largest coconut producer, accounting for more than 30% of global coconut production. Across more than 2.1 million hectares, the country produces over 21 billion coconuts each year, with an average yield of nearly 9,900 coconuts per hectare. But in India, the coconut tree is not just an agricultural crop. It is the livelihood of around 30 million people, including nearly 10 million farmers, concentrated in states such as Kerala, Karnataka, Tamil Nadu, and Andhra Pradesh. From a single coconut, the water can be used as a drink, while the flesh can be processed into coconut oil, coconut milk, dried coconut, or food ingredients. The coconut shell can become charcoal, fuel, or handicrafts. The problem lies in the outer fibrous husk. It is light, porous, bulky, takes up a lot of space, and is difficult to transport over long distances at low cost. As the coconut processing industry expands, the volume of this byproduct also increases. Notably, only around 30% of coconut husks in India are currently used effectively, meaning the rest remains a massive resource that has not yet been fully exploited. In small-scale processing areas, coconut husks were once piled up along roadsides, beside workshops, or near collection points. They are not toxic like plastic, but they decompose slowly, take up space, and can produce smoke and dust if burned in the open air. It is this paradox that makes coconut husks valuable. Inside the layer once seen as waste are strong coir fibers, moisture-retaining cocoa peat, and carbon-rich coconut shells, materials that can open up an entire new recycling chain. In India's coir industry, erosion control nets are among the higher value products. In a country that regularly experiences heavy seasonal rainfall, hillsides, canal banks, and agricultural land are highly vulnerable to being washed away by water. For this reason, nets made from coconut fiber have become a natural solution for holding soil in place and restoring vegetation. The process begins with coconut husks after the water and flesh have been removed. The husks are collected, soaked, or softened so that the fibers can be separated more easily. Then, fiber separating machines break apart the thick husk layer, separating the long fibers from the cocoa peat and fine dust. The long coir fibers are then cleaned, dried, and combed out to remove impurities. After that, they are twisted into longer and stronger strands. This is the main material used to weave the nets. Once the weaving process is complete, the coir nets are rolled into large rolls for transport to construction sites. In areas that need erosion control, the nets are laid directly over the leveled soil surface, then secured with wooden stakes, bamboo pins, or metal anchors. What makes coir nets special is that they do not protect soil in a rigid way like concrete. When rain falls, the coconut fibers help slow down the flow of water, reduce the force of erosion, and retain the topsoil. As a result, grasses and plants have more time to take root and regrow. Over time, the coir gradually decomposes and returns organic matter to the soil. This makes the material suitable for projects that aim to limit plastic use, reduce concretization, and prioritize solutions that are closer to nature. Alongside the long coir fibers used for weaving nets, the small fragments left over after the coconut husk separation process are also not wasted. During fiber extraction, machines break the coconut husk into two main parts: long coir fibers and fine fibrous dust. This dust is cocoa peat, a type of growing medium now widely used in modern agriculture. The treatment process begins when the cocoa peat is separated from the long fibers. It is then washed to remove dirt, impurities, and reduce the natural salinity remaining in the coconut husk. Next, the material is dried, ground, screened by size, and checked for quality. The parts that meet the required standards are compressed into blocks, packed in bags, or made into specialized growing bags for agriculture. What makes cocoa peat special is its ability to retain water very well, while still allowing enough air for plant roots to grow. In greenhouses growing tomatoes, strawberries, cucumbers, flowers, or seedlings, cocoa peat helps roots anchor firmly, retain moisture for longer, and reduce dependence on natural soil. For areas with degraded soil, saline soil, or difficult farming conditions, this growing medium opens up a cleaner and more controllable way to grow crops. From fibrous dust once seen as a low-value byproduct, India has turned cocoa peat into an important export product. Today, the country's coir products are present in 121 countries, with export volume of more than 1.3 million tons each year, reaching markets from the United States and China to Europe, Australia, and the Middle East. What would happen if the coconut husk you threw into the trash yesterday came back today in the form of a mattress worth hundreds of dollars? It may sound unreasonable, but in India, after the coconut water and flesh are removed, the thick outer husk is sent to factories for fiber extraction. The long, tough, and durable coir fibers are cleaned, dried, and then combed out to remove dust and impurities. Next, they have to be curled to create natural elasticity, almost like tiny springs made from plant fibers. After that, the curled coir fibers are steamed or heat-treated to retain their shape. Once they reach the right moisture level, they are spread evenly into thick layers on the production line. This forms the core that gives the mattress firmness, breathability, and support. Next, the factory sprays latex, or natural rubber, onto both sides of the coir layer. Latex acts as a binder, helping the fibers stick firmly together while still maintaining elasticity. From here, the rubberized coir sheets are cut to mattress size, pressed to adjust their thickness, cooled, and then covered with fabric. The difference of a coconut fiber mattress lies in its breathability. Because the inside of the mattress core is a network of natural fibers, air can circulate better than in many dense materials. This makes coconut fiber mattresses popular in hot and humid climates, where users need a firm, cool sleeping surface that does not trap too much heat. Beyond serving the domestic market, India's coir products are now present in more than 100 countries. In fiscal year 2025 alone, India exported more than 1.3 million tons of coir and coir products to 121 countries. In India, coconut shells are collected from coconut processing facilities, then cleaned to remove any remaining flesh, sand, soil, and impurities. Next, they are sun-dried or mechanically dried to reduce moisture. This is an important step because the drier the shells are, the more stable the anaerobic burning process becomes, producing charcoal of better quality. Once they reach the proper dryness level, the coconut shells are put into carbonization kilns. Under the effect of heat, the organic matter in the shells gradually decomposes, water vapor and volatile gases escape, and what remains is solid black carbon. After leaving the kiln, the coconut shell charcoal is cooled, crushed, and screened by size. Some of it can be sold as fuel for cooking, furnaces, or small industrial facilities, but the higher value portion continues to be processed into activated carbon. To produce activated carbon, coconut shell charcoal goes through an activation process using steam or high temperature. This step creates countless tiny pores inside the charcoal particles, increasing their surface area and absorption capacity. Thanks to this special structure, activated carbon made from coconut shells can retain odors, colors, organic impurities, and many pollutants in water or air. For this reason, coconut shell activated carbon is widely used in water filtration systems, air purification, wastewater treatment, the food industry, and many other manufacturing sectors. From a hard shell layer that once seemed useful only for burning, Factories can create a high-value filtration material that serves both everyday life and modern industry. Not every coconut shell goes into the charcoal kiln. Some shells with beautiful shapes, hard surfaces, and a natural brown color are kept for a more delicate journey, becoming handicrafts. Artisans select shells with few cracks, a beautiful curve, and a surface thick enough to work with. They then begin cutting the shell into two halves, drilling holes, grinding the edges, sanding the surface, and polishing it with natural oil or wax. After just a few steps, the originally rough shell gradually reveals a glossy brown color, natural grain patterns, and shades that are never exactly the same from one piece to another. From a small coconut shell, people can create bowls, cups, spoons, decorative lamps, buttons, storage boxes, bracelets, earrings, mini plant pots, or souvenirs for tourists. Coir rope is one of the oldest products in India's coconut industry. In coastal areas, this type of rope was once used for tying goods, securing objects, agricultural use, fishing, temporary construction, and many everyday handicraft tasks. The long coir fibers are straightened, gathered into bundles, and fed into rope twisting machines. Many small fibers are twisted together to form thin cords. Then several thin cords are twisted again to create larger ropes, depending on the required thickness and purpose of use. After completion, coir ropes are rolled into large coils for transport to other workshops. Some are sold directly as tying ropes for agriculture, gardening, decoration, packaging, or handicrafts. The rest becomes an intermediate material for weaving mats, making erosion control nets, hanging planters, baskets, small furniture, and many other bio-based products. Compared with plastic ropes or nylon ropes, coir ropes are not always stronger in terms of tensile strength or lifespan. For this reason, coir rope is not only a traditional product, it is also an important link that helps India's coir industry move into many new fields. Among the many products made from coir mats are probably the most familiar. They appear in front of homes, in hotels, restaurants, resorts, and even in spaces that need a durable, naturally rough mat capable of cleaning dirt from the soles of shoes. After the coir fibers are separated from the husk, the long and strong fibers are selected specifically for making mats. They are cleaned, dried, combed out, and then classified by length and coarseness. For traditional woven mats, the coir fibers are spun into long yarns before being placed on a loom. There, the fibers are woven horizontally and vertically to create a firm, thick mat with a naturally rough surface. It is this rough surface that helps coir mats scrape away soil, sand, dirt, and water from shoes better than many ordinary soft mats. In more modern factories, coir fibers can be fed into tufting machines or pressing machines to create mats with uniform sizes. Some types are also dyed, printed with patterns, trimmed around the edges, or coated with an additional rubber or latex layer underneath to increase grip and reduce slipping on floors. Thanks to their durability, abrasion resistance, and plant fiber origin, coir mats are not only a familiar household item, but also a product with a more eco-friendly image compared with many mats made from synthetic plastics. Of course, coconut husk recycling cannot solve every environmental problem on its own, but it shows a very noteworthy direction. Instead of treating agricultural byproducts as a burden, we can turn them into resources, creating additional income for farmers, jobs for craft villages, and more sustainable products for the global market. Which product made from Indian coconut husks impressed you the most? Erosion control nets, Coco peat, coir mattresses, coconut shell charcoal, or handicrafts?
Not every oil spill begins with an explosion. On August 11, 2006, the oil tanker MT Solar One sank silently off the coast of the Philippines. The vessel, chartered to transport industrial fuel, suffered a failure caused by severe structural deterioration combined with overloading, leaving its hull unable to withstand rough sea conditions. There were no dramatic warnings and no major distress signals. The ship gradually lost stability and sank to a depth of approximately 3,000 feet. Going down with MT Solar One were 550,000 gallons of bunker oil, a thick, heavy fuel with strong adhesive properties, commonly used by large ocean-going vessels. At the moment the ship disappeared beneath the waves, the Philippines had yet to grasp the true scale of the disaster that was unfolding. Unlike lighter oils, bunker oil does not spread quickly across the water's surface. Instead, it clumps together, sinks, and adheres stubbornly to rocks, mangrove roots, and coastal sand. These characteristics make leaks difficult to detect early and nearly impossible to clean up using conventional response methods. Just days later, the first traces of oil began to appear along the shoreline, signaling that a maritime accident had escalated into the most serious oil spill in Philippine history. From that point on, MT Solar One was no longer merely the story of a sunken ship, but the beginning of a prolonged environmental crisis that would last for years. Located in central Philippines, wedged between the islands of Panay and Negros, Guimaras had long been accustomed to the gentle rhythm of the sea in the Iloilo Strait. Yet it was precisely this strategic position, guarding the entrance and exit of these waters, that made the island the most visibly affected when oil from the MT Solar One spill began drifting ashore. Before the incident, Guimaras was known as a quiet island, celebrated for its white sand beaches, fertile mango orchards, and the Tacloban Marine Reserve, an area where coastal ecosystems had remained relatively intact. The sea was not merely scenery, it was the lifeblood of the local community. But within just days of the oil spill, that picture changed completely. Bunker oil from offshore was carried by ocean currents toward the coast, contaminating more than 1,500 hectares of ecosystems. Mangrove forests were coated with oil along their roots and lower trunks, seagrass beds were smothered, and coral reefs in the area were directly affected at the height of a sensitive spawning season. Among the hardest hit areas was Tacloban Island, the very heart of the marine reserve. The disruption extended far beyond the environment. As coastal waters became heavily polluted, authorities were forced to impose a total ban on fishing. Nearly 20,000 fishermen lost their livelihoods almost overnight. Many families left the island for Manila in search of temporary work, while some children were forced to interrupt their schooling as household incomes collapsed. At the same time, tourism, the economic backbone of Guimaras, was brought to a near standstill. Beaches that once attracted visitors were closed, activities within the marine reserve were suspended, and the revenue that had sustained the community vanished. Losses were estimated at billions of pesos, underscoring that the oil spill did not merely devastate an ecosystem, but plunged the entire island into a profound socioeconomic crisis. After oil began washing ashore along the coast of Guimaras, the Philippines quickly activated its full set of oil spill response procedures in line with international standards. Containment booms were deployed to corral the slick, mechanical skimmers, and absorbent materials were brought in, and specialized teams attempted to deal with contaminated sediments. On paper, these were well-established measures, techniques used in many countries and proven effective in past incidents. But the reality in Guimaras was entirely different. Bunker oil, thick, viscous, and tar-like, did not spread quickly enough to be contained. Instead, it clumped together, clung stubbornly to rocks and mangrove roots, and mixed into the coastal sand. Equipment designed for lighter oils became slow and ineffective against this type of fuel. The more responders tried to recover it, the deeper the oil was dragged into fragile coastal ecosystems. The situation was even more dire in the Tacloban Marine Reserve. Located far from the mainland, with narrow access routes and limited infrastructure, the area was almost impossible to reach with heavy machinery. The Philippines also lacked specialized cleanup vessels or high-capacity skimmers like those available in the United States or Europe. As time passed and oil continued to accumulate, modern technological solutions gradually remained only on paper. Ultimately, under mounting pressure as contamination spread, the Philippines was forced to choose the simplest and most bitter option of all: mobilizing local residents to collect the oil by hand. As standard cleanup measures stalled one by one, the Philippines was forced to search for an alternative solution. In that context, an idea that sounded almost unbelievable began to circulate, using human hair to absorb spilled oil. Thousands of hair salons across the Philippines were called upon to collect hair. From Manila to smaller cities, containers were placed outside salons, while students and volunteers willingly cut their own hair to donate. The collected hair was then packed into nylon mesh, forming long floating booms that were deployed along the coast of Guimaras and around environmentally sensitive areas. This approach was not entirely improvised. From a scientific perspective, human hair has a high capacity to absorb oil while repelling water, thanks to its surface structure and naturally hydrophobic properties. Each strand acts like a tiny capillary, allowing oil to cling along its entire length without swelling or sinking, unlike many synthetic materials. Lightweight and buoyant, hair booms can remain on the water's surface for extended periods, continuing to absorb oil even under unfavorable sea conditions. As soon as the idea of using human hair to deal with oil spills was put into practice, many scientists expressed skepticism. While some viewed it as proof of the potential of biological materials in emergency response, previous cases showed that the issue was far from straightforward. During the 2007 Costco Busan oil spill in San Francisco Bay, hair mats proved highly effective at absorbing oil. But this very success raised new concerns. Human hair decomposes slowly in marine environments, is difficult to manage after collection, and often contains dyes and styling chemicals that pose a risk of secondary pollution. For these reasons, human hair has been regarded only as a temporary emergency measure, not a sustainable long-term solution. The doubt surrounding the use of human hair left behind an unresolved question. Could the Philippines find another natural material, one that was effective, safe, and durable enough to be deployed at scale? The answer did not come immediately. It would take nearly 17 years after the MT Solar One disaster to emerge. In 2023, a vessel carrying roughly 370,000 gallons of industrial fuel capsized off the coast of Batangas, directly threatening fish farms and nearby coastal communities. Within hours, the sea began to change color, reviving memories of what Guimaras had once endured. But this time, the Philippines responded differently. Instead of turning to human hair or waiting for cleanup equipment from abroad, the Philippine Coast Guard acted immediately. Sacks of dried coconut husks were hauled to the shoreline, tied together into long floating barriers, and deployed into the water to contain and absorb the spilled oil. This decision was not a hasty reaction born of crisis, but the result of experience accumulated over time. Just a few months before the Batangas incident, during a smaller oil spill east of Mindoro, local residents had already tested this approach. They collected coconut husks from around their villages, packed them into mesh, and created improvised oil-absorbing booms. The results exceeded expectations. The oil was effectively contained and easy to recover, while the material was readily available and did not carry the risk of secondary pollution associated with human hair. What was used in the oil-absorbing booms was not raw coconut shells, but coir, the fibrous material extracted during the production of ropes and traditional handicrafts. Lightweight, inexpensive, and naturally oil-absorbent, coir had long been ubiquitous across the Philippines, yet it was rarely recognized as a material with environmental value. Few people notice that the Philippines was once the world's largest coconut producer and remains among the global leaders today. About 26% of the country's farmers depend directly on coconut cultivation, generating millions of tons of coconut husks each year that are ultimately discarded. While coconut water, flesh, oil, trunks, and leaves are widely utilized, the husk, which accounts for more than 1/3 of the fruit's weight, is often treated as waste. This is not unique to the Philippines. The same situation exists in Indonesia, Sri Lanka, India, and Vietnam. Globally, an estimated 85 to 90% of coir goes unused, piling up around processing facilities, even as these very countries frequently face coastal oil spill incidents. It is precisely this paradox that has prompted a reassessment of coir, from a neglected byproduct into a readily available, low-cost resource well-suited to local conditions in the fight against oil pollution. The British recognized the unique value of coir very early on. During World War II, they used coconut fiber to make life jackets, ship mooring ropes, and camouflage nets, calling it the golden fiber of the Pacific. Not because it was rare, but because it was lightweight, durable, buoyant, and resistant to decay in seawater. Modern science shows that coir is far more powerful than people once realized. This material contains around 45% lignin, one of the highest lignin contents in the plant kingdom. Lignin acts like a natural oil magnet, allowing coir to absorb oil efficiently while repelling water. Its twisted, porous fiber structure, filled with millions of microscopic capillaries, enables coir to trap crude oil and even absorb heavy metals commonly found in industrial pollution. Compared to human hair, the difference becomes clear. Hair is effective only in the short term, difficult to handle after recovery, and carries the risk of bringing salon chemicals into the environment. Coir, by contrast, is a clean agricultural material, stable in salt water, and can be reused or safely treated through biological processes. It is precisely this sustainability that allows coir to move beyond a stopgap measure and become a long-term option in oil spill response strategies. While biological solutions such as coir are gaining attention, a troubling reality continues to unfold quietly. Oil spills on a global scale are once again on the rise. Although the number of major oil spills has declined compared to the 1980s and 1990s, their frequency over the past decade has increased relative to the period before, especially in regions with dense maritime traffic across Asia, Europe, and South America. In 2024 alone, 6 major oil spills and 4 medium-scale incidents were recorded, releasing a total of nearly 22 million pounds of oil into the ocean. The reasons are not difficult to identify. Ships are becoming larger, weather patterns more extreme, and the volume of oil transported by sea remains exceptionally high. Even countries with advanced technological capabilities are not immune. In the United States, oil spill response still relies largely on familiar measures, deploying containment booms to confine slicks, using large-capacity skimmer vessels to recover oil from the surface, and combining these efforts with monitoring systems based on satellites, aircraft, and drones to detect spills early and track their movement. However, these approaches come with very high costs and depend heavily on modern infrastructure, making them difficult to deploy quickly in small island regions or developing countries. This contrast underscores a critical reality. There is no single solution that works everywhere. And it is precisely here that locally available biological materials like coir are opening up a more affordable, flexible path forward. From human hair in moments of emergency to coir, a seemingly worthless agricultural byproduct, the Philippines has shown that solutions do not always have to come from expensive laboratories or global supply chains. Sometimes they lie right within local natural conditions and the knowledge of the communities themselves. What do you think about this approach? Share your perspective, and don't forget to subscribe so you won't miss the next journeys with Terran Works.